We'll now take a look at the final 12 slides in 6.1. Euler's theorem. Euler's theorem is divided into two parts. One part, if you look at the degree of all your vertices and you have no odd vertices, in other words you have all even vertices, then your graph has an Euler circuit. But if you look at your graph and it has exactly two vertices of odd degree, then it's going to have an Euler path. It can't have an Euler circuit. You can't start and stop in the same place, but you can go over each edge exactly once. So you will have an Euler path, but not an Euler circuit. Now, if you have more than two vertices of odd degree, then it won't have an Euler circuit or an Euler path. So let's look at some examples of this. So we want to know if this has an Euler circuit, an Euler path, or neither. So Salem, the degree is 1, Portland is 3, Boise is 1, Olympia is 2, Seattle is 2, Spokane is 1. So looking at this, does it have all evens? No. So it can't have an Euler circuit. You can't cover each edge exactly once and start and stop in the same place. Does it have an Euler path? Well, I have 1, 2, 3, 4 odds. Euler path says I need exactly 2 odds, so it doesn't have an Euler path. It has neither. Another example. If we find the degree of each vertex, we have 4 here, 4, 2, 4, 2, and 2. So notice that they're all even. If they're all even, then you have an Euler circuit. Fleury's algorithm. Fleury's algorithm is a step-by-step process that takes you to the answer when you're trying to find an Euler path or an Euler circuit. Now, with Fleury's algorithm, the book has you keeping up with 2 graphs at one time. You can use their method or you can use my method. It doesn't matter to me, especially since I won't be seeing a lot of your work. For Fleury's algorithm, the main rule is don't erase a bridge. If you erase a bridge, put it back and go the opposite direction. And as we go through this graph, we're going to be erasing it. And in the end, when the graph is gone, we will know that we have found our Euler circuit. So you start by testing to see if this thing even has an Euler path or an Euler circuit. Well, degree is 2, 2, 4, 2, and 2. All evens, so you know you have an Euler circuit. So what I'm going to do is I'm going to draw the graph. Just going to recopy what we already have. Alright, just redrew what we had. And let's say we start at A. A, we have a choice. We could go to C or D. It doesn't matter which one. So let's say I choose to go to C. I can erase that edge and I add to my list. I went from A to C. Now that once I'm at C, I can't go to D because if I erase D, then I've disconnected my graph. That would be erasing a bridge. So I have to go the other direction. I either need to go to B or I need to go to E. So I'm going to go to B. So I'll erase from C to B. Now I'm at B. I'm going to go to E, then C, then D, then A. Because at this point, you can see the path that you need to take. But we'll take it step by step. B to E, Take my eraser, erase B to E. Since all of my edges are gone from B, I can also get rid of vertex B. So now I'm at E. I have to go to C. So I can erase E to C. And all of my edges are gone, so I can erase E and point E. C, I have to go to D. Take my eraser, C to D is gone, and I can erase C. Then D, I have to go to A. So my entire graph is gone. And once my graph is gone, I know that I have completed my Euler circuit. Okay, the bridges of Königsberg. This is where all of graph theory actually started. Königsberg, the people of Königsberg, they lived on these islands, and this is back before Xbox or Nintendo Wii or television, or probably even before bicycles, who knows. But they used to go out and they would travel over each bridge, and their goal was to travel over each bridge exactly one time without going over a bridge twice. So some people said, I have tried this and tried it and tried it and tried it, and I've never been able to do it. And other people said, oh, well, I went out and I was able to do it the first time, no problem, but they never could tell exactly how. So this mathematician named Euler came up with this way to find out whether these people were telling the truth or whether they were lying. And that became graph theory. So what we do is, these dots are our pieces of land. The left bank, the right bank, the top island, and the bottom island. And we want to see if they're telling the truth or not. Well, that means that they must have an Euler path or an Euler circuit to go over each one of these edges, or in their case they were bridges, exactly once. So this vertex has a degree of 3. This vertex has a degree of 5. This one is 3, and this one is 3. So Euler circuit, they should all be even. So there's no way that they could start at their home and go over each bridge exactly once and come back home. So that's not possible. No Euler circuit. Euler path should be exactly 2 odds. Well, we have 4 odds. So there's no way that they could start in one place, travel over each bridge exactly once, and end up somewhere else. So it was impossible for them to travel over each bridge exactly once.